Good morning, everyone. Good afternoon, good evening, depending on where you are. Today we'll be hosting a webinar talking about some of the quick steps that we can have to engineer a bespoke multi-cluster Kubernetes platform. I'll be your host today. So I'm Daniel Virassamy. I'm a principal cloud solutions architect. I live in Paris. And I've always been in the open source world, right? So I've been working at a very early stage in my career on Linux. And then I had the opportunity also to work on OpenStack as an open source infrastructure as a service platform, and then Kubernetes since its inception. So I'm curious by nature, but open source by choice.
Need to learn Kubernetes quickly? Check out our free ebook with hands-on exercises you can complete on your laptop over a short break or lunch. Visit mirantis.com/learn K8s to download now.
So let's directly now deep dive into what I want to share with you today. So let's look at the landscape, right? Let's start with the landscape of multi-cluster management systems. We do have a few options today coming from various environments, whether it is public clouds, whether it is private clouds. If you want to go hybrid, multi-clouds, right? You have these options coming from the main free public clouds, as you AWS, Google. You can have Kubernetes as a service offering with Rancher, with OpenShift, with Tanzu, with Mirantis Kubernetes engine. So you do have these options, right? I'll go through some of these limitations that I've observed in the next slide. But as part of the landscape, we do have a couple of options. All of these solutions, whether it is again Mirantis Kubernetes engine, whether it is EKS, they are all built to be enterprise ready, right? So they are all built to offer proper security components. They are built to comply with Kubernetes scalability requirements. They will provide performance when deployed properly and configured properly. And they will also have high availability and resiliency capabilities, depending again on how the underlying infrastructure is built, right? So you do have these solutions that will help you deploy your environments under proper architectural, I would say, principles. But what are some of the limitations and actually what we want to solve, right? Why is this not enough? Let's look at simplicity. I think one of the metrics or one of the KPIs that we can look at is, in terms of simplicity, is how long does it take to deploy a given Kubernetes cluster? Are we talking about minutes? Are we talking about hours? Are we talking about days or weeks, right? And this, it can be done, and we can monitor that on various environments. If we talk about virtual machines, for example, on an opinionated platform, right? You can have proper metrics. You can have, I would say, not proper metrics, but that you can have proper KPIs in the sense that you can deploy clusters in a few minutes. But if we put that in a more customized environment, like physical servers, in that case, this can be a little bit more tricky. And this is where we move from basically hours to days of deployment, right? So it's not always that simple. Let's look at bespoke as a second element or a second limitation. Very, very simple things, right? Do you have access to the source code? Can you change the source code? Can you change things like a UI? Can you change core components of the solution? Like, for example, you don't want to use etcd as the database, but you want to move to PostgreSQL, for example, right? Can you do all these customizations for some of these solutions that are available as part of the landscape? Not always. Some of them you can, some of others you actually cannot. Is it a true multi-cloud? And when I say multi-cloud, I look at app mobility. Not always the case. Again, not always the case, simply because some of these solutions are made to lock you in, right? And that's also related to the zero lock-in principle. Is it easy to move clusters, or sorry, applications from a cluster running in AWS, like EKS, towards a cluster running in Azure, AKS? Not that easy, right? It's not made to be multi-cloud. It's many of these solutions are made to work and operate in a single environment, right? So that's also one of the limitations that we would want to solve. Cost optimization, you have all the knobs that you can tweak to reduce the cost. How is it attached to licensing? Is it attached to an operating system licensing? Is it attached to a core licensing? Is it attached to node licensing, right? So all of these, you also need to have all that, or at least that level of flexibility to reduce the cost. And then finally, what is your level of access to the platform? Are you a full admin or operator of the platform, or are you a user of the platform, right? It's very, very different things. Again, as an example, can you tweak the etcd database, or can you tweak any other components of Kubernetes to make it as performant as you want? Not always the case. And this is, again, something that we want to solve, right? And how I'm going to present this today is mainly around open source initiatives. But obviously, you can also combine some proprietary solutions into the equation, right? So it needs to be a mix of your best solution depending on your environment, right? Where you can use open source, I would definitely recommend to use open source. Where you need to use closed source solutions, then find a way of integrating that into the full picture. First thing is the infrastructure, right? You need to be running your Kubernetes clusters on top of an infrastructure. So for this, basically, we do have various options today and various requirements. Public cloud or clouds, right? Where you will have virtual machines primarily, is an environment where that you can use to host your Kubernetes clusters, right? And various Kubernetes clusters across the different regions of public clouds. Bare metal is another environment where you would want to also host your Kubernetes clusters. Let's say you want to have host applications for AI/ML use cases. You need to leverage GPU and vGPUs for these applications. In that case, bare metal typically fits very, very well to these use cases. So you also want to be able to manage and handle Kubernetes clusters at scale on top of bare metal, right? And again, if we look at limitations and some of the things that we want to solve, look at it in a simple way, in a fully managed way where you are an operator and you can tweak everything to get the best of the underlying platform. VMs can be in public clouds, but can also be in private clouds. This is something that you also want to leverage. And then whether you are more looking at an edge scenario or scenarios, like, for example, for telco clouds, you have very, very specific requirements there in terms of footprint, in terms of power consumption. And basically, you also need to take that into consideration. And sometimes you also don't have access, or you are not allowed to have access to the external world. So you are in a completely air-gapped environment. This also needs to be taken into consideration, right? So all of these environments are potential target environments. And sometimes it's not even exclusive, right? So meaning that I'm only going to use public clouds, or I'm only going to use private clouds with VMs. It can be a mix of all these things, right? You can have one single platform that needs to manage all these different environments. And this is where also the bespoke is important, because many of the solutions that we have as part of the landscape, which are coming out of the box, do not provide that capability, or multiple capabilities to address the management of Kubernetes clusters across all these different environments at the same time, simultaneously, right? So let's look at an example. So here, for example, I want to deploy a solution on top of multiple availability zones, right? So that's a region. One region, multiple availability zones. Typically, you would need to have at least 3 physical sites within a 10 or 20 kilometer range, so that you reduce the latency, right? So you manage that latency below 10 millisecond sub-millisecond latencies, sub 10 millisecond latencies, right? You don't need to deploy your clusters across all sites. You can keep 2 sites to deploy your clusters and keep 1 for quorum, or you can use all 3 sites to deploy all your different entities, right? So in this case, how that will look like is you will have your management cluster deployed across your different data centers. So let's say, for example, here in data center 1, I have a management cluster. In data center 2, I have another management cluster. And in data center 3, I have a third management cluster, right? Either you have one single cluster, so you are, in this case, it's not clusters, but it's nodes that you are distributing across these different data centers. And you can use 2 active and 1 for quorum only. Or you can actually have proper clusters, so 1 cluster, 2 clusters, 3 clusters, and then you use components like Kube Federation, for example, to make sure that you are able to deploy components or pods across these different clusters, right? And once you have that setup, that base setup, you are ready to start to host the different Kubernetes clusters that will be managed by that management cluster, right? So this is what we also call child clusters. In this example here, what I have is I have one single cluster that has stretched across 3 data centers. So that's 1 node, 2 node, and a third node for quorum. And I am only using DC1 and DC2 to deploy my child clusters, and these child clusters are running in virtual machines. All right. Once I have defined that for one single region, then I can replicate that for multiple regions, right? So this is also where you have, again, that region concept, one region with that pattern, and then you replicate that across other regions, right? So that's for the underlying infrastructure. What are some of the core infrastructure services that you want to deploy? One thing that you may consider is the capability to have hard multi-tenancy. And I think this is important to have that capability to do hard multi-tenancy. One, for security reasons, you want to separate for your different users resources, whether it is at a physical level or it is at a virtualization level, right? So the ability to create tenants, and within that tenants to manage dedicated compute, storage, and networking resources without having a way to have data that is migrated or seen by other tenants, right? So that's that hard multi-tenancy requirement, which is very, very key, and that aligns with security principles. But not only security, because it also facilitates the chargeback or pricing of your service. Because in that case, you only need to monitor the resources that are consumed at an infrastructure level. So how many virtual machines am I using? How many CPUs, memory, and storage am I using attached to my virtual machines? How many public IPs am I using? How many load balancers am I using, right? So all of these can be monitored at an infrastructure level, and then you can charge that back to your customers. So it also eases that chargeback or billing layer, right? And then obviously you will be looking at networking, how you need to build scalable networks, whether it is internal network based on underlay networks or overlay networks, right? You have modern infrastructure as a service offerings now that supports out-of-the-box overlays, right? You don't need to manage only underlays with VLANs, but you can scale that out with overlays, like for example with VXLAN, and also manage your external networks properly Either you have dedicated external networks, which we would also call provider networks, or you have one single external network, internet facing, where you have all your customers connected to. Right? You have also the ability to properly select the storage backends. Right? You have various solutions today, whether you want to use local storage, you want to use software-defined storage solutions like Ceph or Portworx, or you want to have appliances like again pure storage or NetApp, right? So you can have a mix of all of these in the sense that you can always say, okay, I'm deploying a Kubernetes cluster and I want to host databases there. These databases can use local storage, right? Local NVMe for speed. So I'll have NVMe disks attached to the physical servers, and then my Kubernetes cluster will have persistent volumes directly getting the volumes from these local disks, right? But on the other side, you can also have appliances or SDS used for more archival use cases, right? So you can have a mix of these different backends that you combine and you provide using storage clusters in Kubernetes and your child Kubernetes clusters, right? Load balancers is something that basically you can also provide through the infrastructure layer. Typically, this is you have various again options for that depending on the environment that you're using. If you're using AWS, basically you will leverage Elastic Load Balancers. If you're using OpenStack, you will leverage Octavia as load balancer as a service. So you do have options. And if you don't have solutions provided by the underlying infrastructure, you can always use software load balancers. Like typical example is MetalLB. MetalLB would be deployed in your Kubernetes clusters, and as from there, you can also provide and offer load balancer as a service out of the box, right? And finally, some auxiliary services. I highlighted some of these, but these are very, very common auxiliary services that you will need to hook to your through the core infrastructure to your Kubernetes clusters. Identity provider, for example, and if you also want to leverage SSO, then you also need to have an identity broker like Keycloak, for example, to help you do SSO between your management cluster and your child clusters. You will need to have a DNS resolver that will allow you to expose your services externally in an easier manner than just using base IPs. Certificate managers and Vault to manage your secrets and to also manage the certificates so that you terminate TLS communications, right? Once we have built that underlying infrastructure, and again, looking at the various tracks, right? So whether it is public clouds, where we'll mainly leverage the APIs of public clouds, private clouds, again, where we will need to manage the physical part or layer, and on top of that, the virtualization layer, bare metal, where you have again the physical layer, and then edge and air gap, where you have again specific constraints like selection of hardware at the edge, and building a local repository for air-gapped environments. Once you have done all this, we are ready to move to the selection of the Kubernetes distribution, right? And for this, I think one of the best solutions on the market is k0s. You can have a look at the project if you don't already know about k0s. So you can look at k0sproject.io. But basically, k0s is a certified Kubernetes cluster, right? So it's a CNCF certified Kubernetes cluster with the capability to also have FIPS 140-2 certification. And the advantage of k0s is that it can run anywhere, right? It can run on public cloud, it can run on private cloud, based on hybrid and multi-clouds, whether it is on virtual machines, bare metal servers, and it is adapted to edge and IoT use cases, right? Why? Because it is very simple and very simple to deploy in the sense that it is a single binary that incorporates all the Kubernetes components and dependencies, right? So that's the magic of the solution, in the sense that It is a single binary with all the Kubernetes components and attached dependencies, and then you can run that binary on various operating systems. Linux as the default one, but you can also run that on top of Windows operating system, right? So it's easy to build Kubernetes clusters in a very simple manner. What I mean by simplicity here is if you want to, for example, deploy that using a single node with that binary, then it's a couple of commands to call, right? Curl to download it, k0s config to create the k0s configuration file, and then you start to install it using that configuration file and you start the cluster, right? So very small steps, very few steps to allow you to start your Kubernetes clusters. Here we are talking about a couple of seconds to deploy a Kubernetes cluster, right? So it's again, in terms of simplicity, it's made to be simple, simply because it's a Kubernetes cluster that includes everything and that you can deploy in various environments using very little, very few steps. If you want something a little bit more complete with multiple nodes and all that, you can use the CLI, which is called k0s CTL, for example. And in that case, you will create, using the k0s CTL init command, you will create a more complete YAML description of your deployment. And once you have tweaked all these different parameters, you just need to call k0s CTL apply to the file, and basically it will deploy k0s across various nodes, right? So you can have a more complex, highly available deployment in, again, a few steps to get access to your Kubernetes cluster, right? So again, here we are talking about a couple of minutes / hours, depending on the complexity and the scale of your cluster, but definitely not tens of hours or days or weeks to deploy the Kubernetes cluster. Simplicity is something which is very key here, right? And we can also leverage more advanced controllers like cluster API, right? So this is an example of a cluster API definition. And in that case, that also leverages the infrastructure piece, standard cluster API integration, and then we just reuse some of the parameters within the cluster API definition, and we deploy the cluster. All right. The k0s is also, in terms of resources, it does not use a lot of CPU and memory resources, right? So that's a massive advantage, and that's why I said it is adapted to various environments, whether it is public clouds, private clouds, but also edge environments, where basically you have resource constraints, right? So if you have within your environment you have physical servers that do not have a lot of CPU, a lot of memory, or you need to control that, k0s is a perfectly fine solution for that. Not only about the CPU restrictions, resource restrictions, whether it is CPU and memory, but we also look at different architectures here, right? So it's not only x86 architectures, but it's also ARM64 and ARM7 architectures. So for example, you can imagine edge sites where you have ARM64 based hardware, few CPUs, few memory, and you have k0s perfectly running there, right? So this is something which is also very key. Think about bespoke. You can't do that with all the solutions that I highlighted at the beginning of the presentation, right? If you look at the landscape, some of the solutions within that landscape do not allow you to have that flexibility to deploy Kubernetes at scale in edge solutions on ARM64 with reduced CPU and memory. In terms of scale, k0s aligns perfectly with the Kubernetes recommendations. So we can scale in terms of workers, we can scale in terms of pods, we can scale in terms of amount of CPU and memory that is required to properly host these pods on these environments, right? So again, these are standard numbers that we Mirantis have tested with k0s, and that aligns perfectly with the Kubernetes recommendations. Now that we have selected the distribution that will run on top of the infrastructure, we need to find a component or use a component that will manage the lifecycle of the different Kubernetes clusters that you will be deploying, right? So again, it is Kubernetes as a service offering. So you need to have a capabilities to manage all these different Kubernetes clusters and do that at scale. For that, Mirantis innovated with the k0smotron project. So again, it is an open source project that Mirantis developed and is now available to the community. You can have a look at k0smotron.io if you want to have more details about that project. But basically, how it works is that it allows you to transition from a given child cluster model to a new child cluster model. And what is that transition basically is that if you look at Kubernetes clusters as a service, right, and the default way of doing that is that for each and every Kubernetes cluster, you have dedicated control plane nodes and you have dedicated worker nodes, right? So if you have cluster one, you will have 3 controllers, for example, if you need high availability, and 3 workers if you need to deploy applications on 3 workers, right? It can be 1, 2, 3, right? But typically this is one footprint. If you have another cluster, then you need to replicate that pattern and again recreate 3 controller nodes and then as many workers as required, right? With k0smotron, the concept is changed, right? So we change the perspective and we say we don't need to deploy dedicated control plane nodes for each child clusters. What we will be doing is we will host only 3, we will have only 3 controller nodes, right? And within these 3 controller nodes, we will host all the control plane services for all the child clusters, right? Within these control plane nodes. So what we do is we containerize, at the end of the day, we containerize the control plane of child clusters, and we host that as pods in the main control plane management cluster, right? So that's why you see a management cluster where you run k0smotron, only 3 controllers there, and you have all your child clusters. But for all your child clusters, you will only have dedicated, at the end of the day, you will only have dedicated nodes for your workers, whether it is, again, virtual machines or physical machines, but you will only have these. You have a lot of advantage by doing that. The main advantage is licensing. If you're using a platform where you are paying a per node license, then you have, in this case, for only 2 clusters, you have reduced by 50% the number of control plane nodes, thus by 50% your licensing cost, right? So that's one advantage. If you are using public clouds, you are not paying for the EC2 instances or the Azure virtual machine instances, right? So again, you are saving cost. In terms of operation, it is also easier because if you are going to patch your machines, if you're going to patch your operating systems, for example, right? Here again, you're patching not only nodes in this cluster, but you also need to patch these nodes here, right? So again, you are for only 2 clusters, you are dividing by 2 the operational and maintenance of these nodes, simply because you have less nodes, right? We have collocated all the services within only these 3 control plane nodes. So that's only for 2 nodes, 2 clusters. Now imagine this at scale, where you have hundreds of nodes, thousands of nodes, right? So hundreds of clusters or thousands of clusters again. So here, the reduction in cost, the reduction in operational complexity is quite important, right? So that's why we say k0smotron is a very, very key solution to provide Kubernetes as a service at scale, simply because it has this mechanism that allows you to reduce massively your underlying infrastructure footprint, right? If we look at it in a little bit more detail, then you have 2 components that you need to consider, right, with k0smotron. The first one is your management cluster. So your management cluster is a Kubernetes cluster In this case, we have built that Kubernetes cluster using k0s, right? So it is a primary Kubernetes instance where you have Kubernetes running, and we will install k0smotron there. And k0smotron is an operator basically, right? So it comes as a controller plus its own CRD, right? So that's the first entity. Once we have built that entity, we can then start to build the different child clusters, right? And how does that work? Basically, you define or you describe the properties of your child clusters in a YAML file, and you ask k0s controller to consume that YAML file to deploy your child cluster. What will happen when k0s Motron will deploy your child cluster? The control plane will be hosted as pods within that management cluster, right? And I will show you that in a few seconds. But the control plane of your so I can see a question from Adriano Pesuto. How k0s Motron? So how k0s Motron differ from other hosted control plane solution like Hypershift by Red Hat and Kamaji by Classic. Okay, so that's a good point. I think so we have various, as you said, Adriano, we have various options on the market in terms of hosting control plane, right? We have the concept of containerizing the control plane. So that's one element. We also have the concept of doing vClusters, right? So again, it's a little bit different concept. The interesting part, I would say, around k0s Motron, right, is that it's not related only to one single solution, right? So in the sense that k0s Motron can run on any Kubernetes clusters. As long as it is a standard solution, it can run on any Kubernetes solution. So you don't need to have k0s Motron running on k0s actually. The management cluster can be OpenShift, or your management cluster can be Rancher, right? So that's one element. The second element is that k0s Motron has collocated only the essential services within the control plane, right? So you only have a few services like the etcd database or kind database or Kube API pods, right? So it's reduced to the minimum so that it doesn't the footprint of the services is very low, right? And the reason we need that is to scale. We want to be able to scale out the number of control plane pods that we can manage within that management cluster. So the footprint is very low, meaning that all then the required services like kubeproxy or core DNS, right, are hosted on the worker nodes, right? Can show you that directly here. So if you look at so I'm using Lens here to connect to various k0s instances. And here I have one running in AWS, right? So this is I would say the management cluster. And within that management cluster, I don't have a lot of nodes here. I have one control plane node and one worker node, right? And what I have deployed basically, and related to what I explained, is that if I look at pods, I have deployed a k0s Motron controller, right? So this is an basic an operator, right, with its attached CRD. So here, if I go to k0s Motron, there are notions of clusters and joint token request, right? So this is again very standard things. And to define a child cluster, I define it in as a YAML file with the kind cluster, right? So which is understood then by the operator, and I link it to the basically I link it to the management cluster, right? So I put the external IP address here, whether it is an URL or whether it is an URL or an IP address. I define the target version, right? And once this is done, I apply that file, right? So kubectl apply that kubeconfig file, right? And what will happen if I apply this file is basically I will have the control plane here deployed. So yeah, in that case, I haven't selected a namespace for this, but I will have the pod that will run the control plane, right? But it's only a sub part of the control plane in the sense that again we have reduced that to the minimum, right? If I go to this environment which is VMware related, which is a little bit more complete because I have child clusters attached to it, you can again see that I have in the pod multiple child clusters, right? But if I connect to one of these child clusters, I go to pods, I go to kube system, right? You will see that those complementary services like core DNS, connectivity, kube proxy, kube router, the CNI, right, or the CSI, they are running on the workers, right? So that's a big difference that you will see. So one is the capability to run it on any Kubernetes. Two is the ability to we have a small footprint, right, to scale out, and three is we can mix the versions. So the master node can have a dedicated version. The child clusters can have various versions, and even the workers can have different versions of Kubernetes, right? It's not a recommended pattern, but this is the level of flexibility that we can have with k0smotron. I would also add that k0smotron is open source. So you can, right now, go into the project, look at the source code, and add features and add any customization that you need, right? And again, if we relate back to the bespoke element of this presentation, that's also the advantage of using these open source projects, is the ability to contribute to these projects and make it a more custom solution for your requirements, right? I hope I answered your question, Adriano. I will send you a more detailed information if you want on how we compare against Hypershift and Kamachi. Okay, so now that we have k0s as the selected solution or distribution, and we have k0smotron to manage the lifecycle management or to do the lifecycle management of the child clusters, whether it is on the control plane side or the worker side, we need to be able to find a or to hook that with infrastructure, right? So you can use Terraform, for example, to do infrastructure as code. You can build your own automation around how to manage infrastructure, but we have started to include cluster API concepts within k0s and k0smotron, right? We will have a more detailed webinar around cluster API. I will give you the dates at the end of the presentation. So, where we will explain in more details how we integrate with AWS with Kappa, or VMware with KAPV, or OpenStack with Capo, right? And even physical machines, because we have a specific implementation of cluster API for physical machines, where we use SSH to manage some of the infrastructure capabilities. So again, Cluster API is a standard project coming and managed within the CNCF. We haven't patched Cluster API to make it compatible with k0s and k0smotron. So the integration is pretty direct, I would say, where you would deploy, depending on your environment, right? I would say the standard Cluster API components, and then the per environment specific components. Like, for example, this is where you have KAPI plus KAPV or KAPI plus Kappa, right? So very, very standard integration. And as from there, once you have integrated the Cluster API components, you can then start to define the child clusters using code, right? So if I go back to the example of VMware, so VMware here have integrated KV within the management cluster. So if I go to the KP system namespace, I will have the KP controller or the operator deployed there. And then if I go to the KV part, I will have the KV specific controller, right? So again, very standard integration. Once I have done that, then that just to move to the proper repository. Once I've done that, and then just need to start to define my child clusters. So this is an example, right? So I have my child cluster 0 here. So you can see I have 4 child clusters, 0, 1, 2, and 3, right? So I have four definitions of these child clusters, right? And here you will recognize all the different, all the standard definitions of a cluster through the KP definition, right? So again, we will have a more detailed webinar around that. But if I wanted, for example, to add more nodes to a given cluster, so for example, in the machine deployment definition, I want to have more nodes to it. See if I go back to VMware, this is where I'm hosting these machines, right? So if I want to have more nodes to these machines, so let's say I want to have 2 nodes, just then need to apply. And in parallel, the machine will start, right? So I have a new machine, right, for the cluster 0, which is started automatically in VMware. And this will be then added to my cluster. So if I go to cluster 0, where I actually had 1 node here because I didn't apply the file. So that's why I have 1 node, and then a new node will appear, right? I'll just need to wait a little bit, and then that node will appear, right? And I think in this case, I mixed versions also because I had an initial node with 127.5 version, and my new node is configured to be deployed on 128, right? So I can also, I know it's properly deploying with the right version. So 127 also. Okay. So this is the new node that I just deployed, right? So basically here, to facilitate the Kubernetes as a service integration with your underlying infrastructure, we will also leverage cluster API, right? So define the deploy the different controllers, and then define these, define your different child clusters with proper definitions. Now we can look at how to kind of add the glue around all this, because these are all, I would say, building blocks, right? I would say the Lego blocks, or the unitary blocks, where you have the distribution on one side, you have the controller on the other side, you have cluster API to make the glue with the infrastructure. But we can then start to automate and provide more user-friendly features using portal and APIs, right? And this is where also the bespoke part is also very important, because if you want to make it yours, then you have that option of creating your own portal, creating your own automation, you creating your own business cases, right? How you want to deploy services, which services you want to deploy, etc., right? So basically, you can manage the different child clusters through that portal, where you would be doing governance, access control, workload optimization, manage the observability part or visibility part, or manage services. I've shown some of these elements using Lens as the UI. But if you want to build something which is a web UI, for example, then basically we come back to the concept of creating everything through APIs, right? So you have that API layer where you will be serving your web services, where you will be serving your CLI, where you will be also doing all your pipelines and automations for CI/CD, right? And actually, all of this can be running in the management cluster, right? Or your where, right? Kubernetes is the right platform to host all these services. So you can use again that primary Kubernetes management cluster, where you will be hosting your API backend, where you will be hosting your API gateway, and where you will then start to serve your HTTP-based web service, CLI, and connect to your CI/CD pipelines, right? Observability and apps delivery then comes on top of that. If you want to start to build kind of marketplace around that or provide capabilities to your customers to deploy applications on top of these child clusters, you can also start to build that delivery platform. So for this, we typically leverage the delivery by code approach, so GitOps approach basically, right? So you define everything in Git repositories, and then through these Git repositories, you would attach that to a continuous deployment component like Argo CD or Flux CD, for example. And you would leverage these pipelines to deploy the different applications across your different clusters, right? So in this example, for example, I have Git as my source of truth. I have two layers. I have a common layer where all the clusters will have that these components deployed by default, right? So you can have this, for example, for logging, monitoring, and alerting. You can say, okay, all my components, I want to have Prometheus deployed in all these different child clusters, right? Or I want to have KubeSpy deployed in all these different child clusters. Or I want to have the security components deployed in all these different child clusters, right? So you can have that common layer where you define, once you deploy the child clusters automatically through automation, these components are deployed, right, in these different child clusters. And then you can have a per cluster customization. You can say, okay, for some of these child clusters, I want to enable service mesh, right, with Istio. So click box, I check the box, and I have Istio deployed in that given specific cluster, right? So all of this then can also be deployed either or defined in the CLI or in the UI, but you can also continue to do that as code using standard Argo CD or Flux CD pipelines. Okay. Here I listed some of the components in the main, I would say, areas that we have as Mirantis that we typically deploy: logging, monitoring, alerting, networking, security, and CI/CD. But you have the whole CNCF landscape here, right? So you can deploy and you can add as many components as you want using that framework, right? But you have another way also of doing that with k0s, which is also interesting, and it's not again exclusive, right? So it's not either the first solution or the other. It can be a mixed, in the sense that you can still use your the GitOps approach or the marketplace approach to deploy your applications in these different child clusters. But you can also leverage what we call the manifest deployer, right? So in k0s, you have something which is called manifest deployer. And manifest deployer will be monitoring a specific directory here in the node, right? So I'll be monitoring the lib is where something manifest directory, right? So this is the default directory that k0s will be monitoring, right? And in this directory, you can populate your specific manifests, all right? Which means that in this case, you can pre-package your bundles so that when you deploy k0s, automatically k0s will look into that directory, look at the manifest that you want to deploy, and automatically populate these applications in your cluster, right? So that facilitates a little bit the provisioning also, where you can have default projects, like again Prometheus, if you want it as being the default, or any security components, if you want these components as being the default. You can have all of these pre-bundled and deployed to the platform automatically, right? So once we have looked at all these different components now, or building blocks. Let's look at the big picture. So this is an example of the big picture, and I'm sorry because it may be a little bit small on your side, but this is an example of where I have one management cluster and two different child clusters, and I interconnect all these using the proper networking configuration, the proper auxiliary networks, the proper storage networks, where I'm exposing my services externally, right? I can have a web portal also to interact with it. So this is where I have started to combine all these different pieces together and make that as a single logical platform. This is an example, but the reason it is bespoke is you can change that completely. You can change the way that you are handling networking. You can change the way that you are handling the child clusters, right? So here all the child clusters are in VMs, but you can also have a mix between VMs and physical clusters, right? So all of these can be made your own, simply because you have all the proper building blocks and you just need to kind of start to glue all these pieces together based on your specific use cases, right? The workflow would look as follows. A typical workflow: a user will connect to the portal. That user will authenticate, right, through that portal and get all the privileges managed between that portal and the identity provider. And once you are authenticated and you have the authorization to create clusters, for example, then the user will create the user, which through the API backend will call the proper action on the k0smotron operator that runs in the mothership, what we call the management cluster, also mothership or management cluster. Once this is done, then the k0smotron will check the privileges. If the privileges are properly set, we'll create the child cluster, and the child cluster again is in two steps. The first step is the control plane as pods that runs in the mothership itself, and then the worker nodes using the CAPI definition, right? That will be hosted on various environments. These can be on VMware, these can be on OpenStack, these can be on public clouds, these can be on physical servers, right? So we have these CAPI definitions to deploy the infrastructure piece and configure k0s within this environment, right? Once this is done, this is where all the auxiliary services and mandatory services can be provisioned, right? So again, we connect it to the auxiliary services, whether it is the identity provider, the DNS, external DNS service, the load balancer service, right? So all of these can be configured automatically, pre-configured using the various ways of doing that. Either we do that directly in CAPI, or we do that with Helm, or the manifest deployer, or any continuous delivery mechanism. And once this is all done, then we push back the kubeconfig file to the user. By default, he will be the admin of that cluster, meaning that he will have full access to that cluster. And it is under the responsibility of that user then to define all the RBAC rules to allow other users to interact with the cluster using the proper kubeconfig definitions. All right. So this is a very standard and simple workflow, but it shows you all the main steps of creating these different child clusters at scale on different environments, right? Again, make it yours, right? So the API backend, for example, can be changed completely. The portal can be changed completely. You have that capability to tweak k0smotron because you have access to the source code. So you can make it your own bespoke solution because you have access to all these different elements. Some of the use cases that we see, Edge and IoT, for example. Is it easy today to build a multi-cluster manager for IoT devices, right? So let's say, for example, you have your PLC devices or sensor devices, and you want to run some applications using Kubernetes at the edge for various reasons, right? Because you want to leverage the life cycle of Kubernetes for updates and upgrades, for self-healing of the components, right? You have reasons why you have valid reasons why you want to run Kubernetes for also these devices. And it's not easy to build or to find a solution that is easily or is made to handle hundreds, thousands of these IoT devices at these different edge sites, right? K0smotron in that case is a very, very valid solution. K0smotron for the multi-cluster management part and K0s for the Kubernetes distribution part is a very, very valid solution, or these two are very valid solutions to start to build your Kubernetes as a service offering for these to manage your different IoT devices, right? Another scenario is the multi-cloud Kubernetes clusters. So here, for example, I have one single management cluster, and that single management cluster is able to manage child clusters on AWS, and I can also manage child clusters on other environments, right? So we gave the example of Hetzner here, but we can do that on Azure, we can do that on OpenStack, we can do that on VMware, we can do that on physical machines, right? So all of this is made to be, again, made to be easy because the workflow is always the same. The target environment is different, but the workflow is always the same. K0s is made to be simple. It's a binary to install, simple to deploy, simple to update, simple to remove, right? Because again, it's a binary that we just install and add to the cluster. And we have various ways of doing that, whether it is a binary install, whether it is a CLI install, whether we leverage Capi. But once we have made or we have built that workflow, we just reproduce that across all these different environments, right? And I'm also thinking of some use cases here that I'm experimenting right now of mixing. Like, for example, I have a control plane on AWS and I'm mixing the node with worker on AWS and worker on some other clusters, right? So this is something that we are experimenting right now to see how that will work out and how we need to manage the resources so that we leverage the proper CSI, we leverage the proper load balancer, etc., across these different environments, right? But these start to build some very interesting use cases, and very interesting use cases when it comes to also application mobility. Because again, we have various ways today of combining or making different clusters work together. Cube Federation is one way, Service Mesh is another way, and maybe this capability to mix workers across different platforms under the control of the same control plane is a way of also handling in an easier manner the app mobility use case, right? So yes, leverage all these different across different views, right? Yeah, let's recap what we've seen here. I think what I wanted to convey during this presentation is make it yours, right? Bespoke is very, very important. You do have solutions available right now as part of the landscape, but you do also have limitations attached to this, right? And if your use cases is not not compliant with what the current offering is providing you, you do have options to make the platform yours and to cope with to make it cope with your use cases, right? So don't change your use case and make it adapted to what the current platforms are offering, but make these platforms or make your platform adapted to your use case. And that's, I think, the very basic idea behind this presentation is you do have options to make that, right? You can have guaranteed success, obviously. You have the choice. You have the choice with open source platforms, open source components, open source projects, right? So you can take back that control and use these open source projects, whether it is K0s, whether it is k0smotron, whether it is all the different CNCF related open source projects that you have for logging, monitoring, and alerting, for security, right? For continuous delivery of your applications. You do have these open source projects that are available that you can use and glue something or build something with the proper glue for your own platform. And you have trusted partners that can help you to deliver faster, right? This is where we, Mirantis, help. And I'm just going to rapidly go through where we help on this front. We have the expertise services right, that can help you accelerate in that journey. We have Kubernetes training services that can help you train and be CNCF certified, right, and get all the proper certifications that you need around Kubernetes. We are backing k0s project because we are at the core of that project. We are backing k0smotron because we are at the core of that project, and we have services around k0s and k0smotron for observability with Lens and Lens App IQ. I showed you a little bit Lens today as the UI, but we are also behind Lens, we Mirantis, and we also have Lens Autopilot or Amizi.io to help onboard applications in an easier manner, right? And all of this under a full stack enterprise certified support if you need enterprise grade support for all these different integrations, right? So if you need to have and build that bespoke solution, or you need help to build these bespoke solutions, we Mirantis are the right player to do that, simply because we have expertise and experience to do that with many of our customers. We do have a few coming webinars. As I said, we'll be doing a more deeper dive into KAPI in the next Tech Talk, November 14th. I'm going to do also another webinar on October 31st, so next week, talking more about the infrastructure piece and how you can evolve your VMware estate. And then we have also a security-related webinar with FIPS 140 certification and Windows containers on November 8th, right? So feel free to register to these if you are interested to learn more about these different topics. And we also have more resources on our website, so Mirantis Press, where we have a lot of or a few books that we provide freely there. We have the blog resources also on our website, and you can look at all our tech talks and previous tech talks and future tech talks on Mirantis Labs. Thank you very much for your time today. You can contact me on my mail, where you can provide your comments and suggestions. Any feedback is more than welcome. And I hope it was interesting for you today, and looking forward to talk to you during the next webinars.